Hi, everybody. I'm Keith Casey. I'm one of your hosts tonight. We've got my lovely Jason Harmon. And making a limited appearance is Damon Klinkscales up here on the right. So what's funny is the three of us founded this group like, what, 2.5 years ago-ish? Something like that. And this is the first time we've all been in the same room together in probably a year and a half. It's been a while. It's been a long while. So anyway, thank you for coming to the Austin API meetup. If you found us, that's a good thing. If you're in the wrong meetup, you've got a few minutes to leave while we're all looking at you. Quick ways to find us online, austinapi.com. That is a redirect to our meetup group, so it's a quick and easy way to find us. Also, Austin API on Twitter. If you want to keep an eye on what's going on in terms of technology stuff, in terms of the API space in general, in terms of APIs in Austin specifically, in terms of like some relevant events and news and everything, that's a great way to do it. Our speaker tonight, when you send out are you going to send out the slides or whatever at the end of the night?
Yeah, I'll send them out.
So I will make sure to tweet them from the Austin API account. So if you're looking for those, we'll go ahead and send that out.
If you have friends that couldn't make it, I just tweeted out the live stream link and the camera's there. So your friends and let them know so they can watch.
Oh yeah, I forgot we get a live stream now.
Oh, wait, fancy.
Welcome to all of our remote viewers. Like 3 of them? 5? I don't know, maybe something like that. A couple other things you guys should know about. I just launched a new Twitter account called ATX Tech Events, as in Austin Tech Events. That is an ongoing feed of I read to meetup groups and then tweets about them. So everything that's coming up, like roughly in the next week or so, it says, hey, here's what's coming up next week, and then here's what's happening tonight. So if you're interested in meetups in general, not specifically just this one, but that's a good way to keep an eye on things. A couple weeks we have RESTfest. Is anyone going? You are, fantastic. So James Higginbotham, who's also regular here, is also going. It's an event in the middle of the mountains in South Carolina? Yeah, Greenville, South Carolina. It's like a big meetup group. There are about this many people in the room, and they get together and they do like a 3-day conference. If you attend, you speak. You know that, right? Mm-hmm. Okay. I just didn't want to blindside you.
No,
yeah.
I'm aware.
Okay, fantastic.
I'm confident in speaking.
Awesome.
Sometimes.
So, so it's funny because a couple years ago I went and they forgot to tell people that if you attend, you speak. And so we had like the first morning, like a lot of people like writing 5-minute presentations. It's only 5 minutes, so it's not a big deal. It's a great place to sort of get plugged in. But after that, in November 18th to 20th, we have the API Strategy and Practices Conference. Does anyone know where that is?
Austin?
Austin! It is right here. It's over at the Sheridan, which is over there by 35. So it's a great event. We're still looking for a handful of volunteers. So if you're interested in being like room monitor, help organize stuff, help greet speakers, like that sort of thing, we do need a handful of people that are interested in that. We had a couple volunteers last month. We still need a couple more. The call for presenters for that is still open. It closes on the 8th, which is next Tuesday, I believe. Yes. So if you're interested in speaking, that is a great opportunity. It's close to home, so there's no flight, there's no hotel, all that sort of stuff. But more importantly, it's a 15 to 20-minute presentation on one topic related to APIs. It can be on cool tools, top tactics. It could be on API strategy, on documentation. You're submitting something, right?
I did already.
Okay, it's fantastic. She already submitted something. Good. It's a way of getting plugged in and sort of seeing what the larger API community is doing. We have some of the best and brightest. If you're familiar with Ken Lane, he's also one of the organizers. Jason, Damon, and I are all involved in organizing, and we're making this happen. It's limited to about 400 people, so if you're not interested in presenting, that's cool. Go ahead and check out getting a ticket as soon as possible, because they will sell fast. Was that anything else? Anything else to announce? Anything else to announce?
Can I just ask, what was the Twitter feed that you just created, the ATX?
ATX Tech Events.
Okay.
Yeah. Yes. Oh, lightning talks next month. Yes. So we want to do lightning talks next month. So lightning talk is you get up here and the target is minimum 5 minutes. We cut you off at 10. As in we pull you off if we have to. But it's a quick and easy way to get familiar with the topic, share something. It can be on a cool tool you found. It can be on an API you found. It can be on something you've built. It can be on a concept that you're interested in, whatever the case may be. It's very broad and open on purpose. So any volunteers right now? No.
I'll do it.
1, we got 1, okay. Do we have a second? 2, anyone else? Okay, that's cool. It's open to everyone. We'll have between 6 and 8-ish, somewhere in there, to go ahead and fill the session. So we've got a couple already, and it's open to everyone. Now anything else? Okay, so with that, we're gonna go ahead and kick off our presenter. He has Legos. How cool is that?
It's the only slide with Legos.
It's the only slide with Legos.
I'm leaving. I don't blame you. I mean, Legos are pretty awesome. So thanks to everyone for showing up. So my talk, as above, is the convergence of Docker and microsystems. So who am I? So my name is Michael. I'm the engineering manager at ReturnPath, or one of the engineering managers at ReturnPath. I'm the one in the Austin office. So I lead the consumer and developer services team, the codes team. That includes the Context.io API and the Unsubscriber and Organizer products. Previously, I was lead software engineer at Silvercar. And even though I'm a manager still, I love to code and hack on things in my spare time, when I can actually find the time, of course. I was going to ask people to hold off on questions because I want some more time at the end to potentially, if people are interested to do a live Docker demo, go over some things. Feel free to if you really want to, but not the end of the world. So starting off, I wanted to sort of talking about like this design pattern, anti-pattern more so, that I've sort of observed throughout my career is, I'm calling it the unruly monolith pattern. And it's generally not intentional. So we start out with a simple monolithic application, and with the best of intentions, we build it and it's decently factored, it's tightly coupled, it's easy to work on, and we say, this time we'll keep it simple, we won't make any mistakes. The problem is well defined, and we know exactly what the business wants. But as time goes on, we learned that wasn't really what the business wanted, and there's all kinds of special case business logic. Different output representations of the same data get added, like JSON, XML, some sort of binary serialization protocol. We think we've solved the problem with what it looks like here. We've added a cool services layer, a few presentation layers. We have a few modules. I've only taken a few shortcuts. We've only tied everything to the user model, nothing else. It'll never be multi-tenant, so it'll be okay. And more time goes on, and we add more data sources, some external integrations, and it keeps getting more and more complex. So boundaries start to erode, and everything's really, really tightly coupled at this point. We even have these worker processes, and we're pushing stuff to a worker queue, like RabbitMQ, and we're pulling stuff off, and it's hitting the same database. It's coupled to internal business logic. We have the abstraction leakage all over the place, and we're wondering, how did this happen? So why did our boundaries erode? And like I said, we had some leaky abstractions and tight coupling. So as the code base of the monolith grows in an organic way, small changes, it starts taking us a lot longer to do anything meaningful in the code base. Small changes are hard. They're bug prone, even if we have really good test coverage. And large changes require us to stop the bus, pull it over, and sort of retrofit everything. Our velocity slows down, which really makes people like Dan Corbin, our product managers, really sad. We're really slow. And unforeseeable issues arise due to coupling, and it's really difficult to break anything apart. So why else? Secondly, with the monolithic application, it's just easier to keep adding things instead of factoring things out or even building something external and new. It's just, we keep tacking stuff on. Or if you're optimizing for speed and your focus is to get things done, you end up incurring a lot of tech debt and tight coupling, trying to move really, really fast and just keep adding on to this monolith and solving business problems, which, to be clear, is solving business problems is great. Making really hard to maintain code, a little less great. So other common problems that arise with monolithic code is, when your team size gets larger, what happens? There's a lot of people touching the same code base, and it becomes pretty hard to manage. It's also, you potentially end up with different people doing different things, various GitHub or Git conflicts, merge conflicts, rebasing's harder. It's just a mess sometimes. So it's also harder to onboard people. We have this whole code base that's really complicated, and we built up these layers of institutional knowledge, like this sediment that just keeps building layer upon layer upon layer. And as time goes on, there's fewer and fewer people that know what those bottom layers of sediment actually do, or why they're there. So other problems, you're stuck in the tech stack that you've chosen. Like, let's say you've chosen Ruby as your programming language and Rails as your framework. usually a pretty decent choice for something when you're trying to get a prototype up and move quickly. You're sort of stuck doing Rails in a lot of cases, unless you're really, really good or really, really careful. Rails is great for a lot of problems, but quite often you're trying to fit a square peg in a round hole. And it often limits you from choosing the right tech for the right job. You might want to go the node route because it solves something really, really well, but it takes too much effort. And there's a lot of other, smaller problems, and I could go on for a long time, but in the interest of time, I don't really want to dwell on it too long. So how do we get back to something like this? Something where it's straightforward and simple and easy to work on. It's simple and beautiful, and in theory, I mean, even Martin Fowler will admit that it's in theory possible to create a well-factored modular monolithic app, but in practice, it's really difficult, and I don't know of any that people have in the long term succeeded with. So assuming we can't make it back to this, and it's too difficult, what are our options? So if we dream for a few minutes and think about it, maybe there's a better paradigm, and maybe we can do better. So to start, let's answer a question. What are some attributes we're looking for out of our systems? So the first is scalability. We build stuff, we want people to use it. We want a lot of users to use our app, and we need to know that the app will scale to handle the load. Traditionally, we scale applications vertically. And what I mean by that is we make the boxes more powerful. And that works for a while. But even Amazon has its limits on what you can fit in their compute engine. So what we want to do is horizontally scale our systems. And so for that, we would be adding more and more nodes instead of simply making the machines more powerful. We also want availability. From an external viewpoint, we never want a service disruption. We want 100% uptime, we want people to use our application, and we want them to love it. And so we need to be highly available. If the application goes down a lot, we won't have many users. We also want agility. We want to solve problems, and the quicker we solve problems, the better. So we want to be able to iterate on solutions. So we want to be able to continuously deploy our changes. So deploy often and potentially test features on a small subset of users, which is also rather difficult to do in a monolithic application. We also want efficiency. I mean, this is sort of obvious. We want to get the most out of our hardware. Idle machines cost money and they don't provide any benefit. A solution that in the past that was utilized heavily was virtual machines. But even that, we're talking about duplicating memory usage, and we're still using hardware virtualization. It's still not as great. And we also want separation of concerns, which is one of the biggest for me. What I want is I want simple, understandable segments of code that do one thing well. I want well-defined interfaces, and I want them to have a single responsibility. If part of the system does something poorly, but has a well-defined interface, we can easily refactor it. We can pull it out, and throw it away. We can rewrite it. We also end up with more reusable computational Legos, as we've defined it, which can help us build systems through composition. So these seem like hard problems to solve. So why do we think we can solve them, and why is this, what about what's going on in the tech world helps us solve it? And how do we achieve our desired attributes for our system that we defined previously? So I'm going to propose that the answer is actually one key technology, which is Docker, and another relatively insightful design pattern, which actually seems a lot simpler than it really is. So we'll use Docker and the concept of microservices to get us where we want to go. And there are building blocks. So let's talk about Docker. So what is Docker? And this is from the Docker website. So they define it as, Docker allows you to package an application with all of its dependencies into a standardized unit for software development. So I mentioned earlier that traditionally in the past decade, most enterprises and businesses have gone down the virtual machine route. At the end of the day, AWS, Google Compute, everything, they're all virtual machines. So how is Docker different from a VM? Well, in a virtual machine, the VM that's running includes the application, the dependencies for that application, an entire operating system, And as you'd imagine, that takes up a lot of, not only hard drive space, period, because you have to have a separate provisioned hard drive for each, but it takes up a lot of memory because you're running a separate instance of the operating system for every single VM. So if you see there's 3 apps running, they all have their own guest OS. And the other key aspect is they're also tied to a hypervisor. So when you think of hypervisors, think of like VMware Fusion or VMware and sort of their hardware hypervisors and all the solutions out there. Hyper-V by Microsoft. You're essentially tying yourself to a hypervisor, so it's not super portable. So Docker containers, how are they different? So they include the application and all of the dependencies for the application. But that's sort of as far as they go. Instead of firing up an entirely new kernel to run the application, they use the host container's kernel, or the container uses the host machine's kernel. The container is run as an isolated process in user space on that particular host. So when you're importing, for anyone who's used Docker, how many people have used Docker? Out of curiosity. Well, that's a lot more than I expected. That's great though. So if you're using Docker and you import Ubuntu in your Docker file, or Arch or whatever else is your base container image, you're just bringing in the supporting pieces. You're not actually bringing in a kernel. You're bringing in user space. So how does this work? So there's a kernel patch that Google released in 2007 that introduced the concept of C groups, and so that's what Docker has been built on. So pretty cool stuff. So the next question is, well, why do we want to use Docker? What does Docker get us? And I've sort of divided this into 2 camps right now, developers and DevOps, although my assertion is that developers versus DevOps is becoming a very blurry line. There's a lot of crossover. So to start, on the developer side, and this actually applies to DevOps as well, less so, but for developers, you can onboard people more quickly. How many people have essentially downloaded like a Ruby, or started a job, gotten a Rails app, had to install RB and env and get the exact version of Ruby, bundle install things, and sort of go through hell there and figure everything out? Probably a lot of people, or virtual env for Python, etc. So.
Just a quick question. It
Yeah.
is going to be available later. Just out of curiosity.
The slides?
Presentation of the slides.
Yeah. I'm gonna put them in PDF form and send them to Jason just right after this. So
We'll tweet them from the Austin API account.
yeah, sorry about that. I totally forgot to give them to him ahead of time. So, where was I?
The hell of installing.
Yeah. I've been through a lot of hell with various things, and I mean, if you're developing on OS X, it's an entirely different setup than what you need to do to deploy to production in Linux. So you have totally disparate sort of configuration environments and such. So sometimes it's really complex to get it set up, and it takes a lot of dependencies, takes a while. And if we're developing it on OS X, most of us are deploying it to Linux servers anyways. So, running it in a virtual machine on a Linux box, it's closer to production actually. With Docker, all you need to do is run a container in order to clone production locally for your typical monolithic Rails app. As far as microservices or services or any of the other paradigms out there go, there's also something called Docker Compose, where you can actually, for development purposes, testing, whatever, link Docker containers together, which is pretty amazing. We use it pretty heavily at Return Path for pretty much everything. So production is running the same container. That's a pretty powerful notion. Computational agency, and what do I mean by that? So at the core, it means developers can get more done. It means they're given the ability to choose technologies based on that technology's ability to solve specific problems. Not because they fit into a Java code base or a Rails app or any language or any tech stack. So with Docker, you can deploy whatever you want, much more easily than you could in a normal world. Couple that with microservices, which we'll get to later, gets a little bit more interesting. Developers start practicing DevOps more, which is a really, really powerful thing. With tooling, and I'll go over some of the tooling that we use briefly at Return Path so that our developers are more efficient and can get more interesting things done. With the tooling, developers don't need to wait for operations to create machines to deploy code to. You got something new, developers in 10 minutes can have that up. Developers just define a Docker file, create a deploy pipeline, and they're off. We'll talk about deploy pipelines, like I said, a little bit later when I mention GoCD. For DevOps, reproducible builds. This is probably pretty self-explanatory, but you expect that pretty deterministic code to do the same thing in different environments. Really important concept. Surprisingly underrated though. Better resource utilization, and this is typically what people talk about when they use Docker. I think it's really important, but it's one of the least interesting things to me personally. But it is really important. Machines that are not doing enough or underutilized, they cost money and they're inefficient. So with systems like Kubernetes, which are people pretty familiar with Kubernetes overall? So Google released this scheduler essentially called Kubernetes at OSCON. It just hit 1.0 about a month and a half ago. We've started using in production. It's pretty cool. So the idea behind it's an open source project that it rolls up all of Google's past experience with, I think it was Borg was their platform that they did everything with. And they had a lot of learnings there, and they've got this whole legacy aspect to it and why they can't easily move away from Borg, and they couldn't open source Borg. And they've gotten to the point where, I was at GopherCon recently and I met with some of the Go engineers, and one of them made a really interesting point to me, and he said, Google's gotten to the point where 10 years ago, the distributed systems knowledge was really centralized in a few people. There wasn't a lot of open source projects around it. And he said, in the past decade, the open source world has actually gotten as good, if not better, than Google alone. And so working with them, they feel that they can build even more amazing things, and so Kubernetes is one of those products. And so Kubernetes is used for scheduling. What I mean by scheduling is that we can balance containers across a large cluster. So we can balance by we have some high CPU instances, and so we're gonna put them distribute them evenly across the cluster, and all they are high CPU. Then we have some low CPU, high memory instances. So we're going to group those together with those high CPU ones because the CPU requirements are low, they require more memory, different attributes, different bottleneck points. And you can even do it by locality. So you can group them together so that if you have multiple applications that need to communicate together, and you really need to reduce latency, you can create little pods of services, essentially, little pods of software that communicate together. And you can have them communicate to the one that's in the same cluster, so you actually have better locality and better performance overall. And so we can cross it out for the most part. There's still, once in a while, you'll still run across something, but for DevOps people that are here, I'm sure that you've heard, well, it worked in dev a lot throughout your career. And I've said that before. Hey, it worked in dev. What's wrong? I don't know. So that's less of a problem, which is great. We can definitely get things done a lot quicker. So this is a Docker file. This is all it looks like. So we'll take a minute to go through that a little bit. So this in particular, since I recognize a lot of people from the Swagger presentation a few months ago, this is actually the Swagger editor Docker file from the repo. And I can show it running later if anyone's interested. Show you how to use Docker a little bit. I've highlighted some of the different commands which are interesting. And just to note, we talked about reproducible builds, and I just want to make it clear that this one's not necessarily reproducible because we're installing things via npm, meaning we're going out to the network and we're pulling things back. So if you were to rebuild this image repeatedly, you could potentially run into problems because you're pulling a new version of something. However, we can pin those dependencies to a local registry of some sort, and we can make this entirely reproducible. So we start out and we say, okay, let's just start at the top, the from. So what that indicates is that's the base image that we're pulling. So we're pulling Ubuntu 14.04. Pretty cool. We're pulling Ubuntu user space inside of a container. Sets the maintainer. So I guess Intuit's a Swagger company apparently, which is cool. And then they're setting some environment variables. Whatever Debian front-end non-interactive means, probably turning off some sort of X system or some X11 system, and then we go through some run commands, and it looks like we're app getting updated updating, we're installing npm, we're deleting some stuff, getting node in there, and then we're changing directories, adding files, installing stuff. And if you get down to the bottom after we've run Bower and we've run Grunt and we've built our app, we're then exposing a port. And that tells Docker where to listen to for incoming network traffic. And then we run our server. That's really easy overall. I mean, a few commands that, if you're familiar with Unix shell stuff, turns out to be really powerful. So how do we then build it? We just run Docker build. And all that line is saying is, okay, so this is from inside that particular repo, to be clear. I can demo this later if anyone's interested. We just say Docker build, and we tag it as Swagger editor. Okay, period, because we want to build whatever's in our current workspace. And then to run it after that's built, it takes, for this one, I built it earlier ahead of time. It took about 15 minutes. There are a lot of node dependencies and things that need downloaded, and the apt repo that it defaulted to wasn't super fast. But once you built that image, you can put it in a local Docker registry, and you can just pull that image down. You don't have to rebuild it each time. You can literally pull it and run it. So we say Docker run. We're going to say, okay, the port we've exposed from that container is 8080, and we want to say, well, expose 8080 to port 8080 on localhost. So the machine that we're running on, we're exposing that. And then we run Swagger editor. Pretty straightforward. That's really it as far as basic usage of Docker without pushing it out to Kubernetes. I'm not going to go through Kubernetes or scheduling in depth or anything like that, but just for development purposes.
What is this container particularly running?
Oh, this is running the Swagger editor. Are you familiar with the Swagger editor? It's a web app. Thought it would be a good example for this particular group.
So it stays on. I mean, when it runs, it doesn't run and die, right?
Yeah. Yeah, I'll show it at the end.
Yeah.
Yeah, definitely. So let's dive a bit into microservices, which is a pretty hot topic these days. Is anyone utilizing microservices at work currently?
Trying.
How's it working out? Is it thumbs up, thumbs down so far? Like, people pretty happy? Okay, cool. So yeah, pretty hot topic. So what is a microservice? I don't really know because there's no official definition of what a microservice is. There's a lot of competing definitions. Martin Fowler has his own, Adrian Crockford has his own. They generally intersect pretty well, but there's nuances. So I particularly like the Wikipedia definition. Whoever wrote that, it resonates pretty well with me. So in computing, microservices is a software architecture style in which complex applications are composed of small independent processes communicating with each other using language-agnostic APIs. These services are small, highly decoupled, and focus on a small task, facilitating a modular approach to system building. So let's sort of dive into that a little bit. What are some properties of microservices? They're loosely coupled. What do I mean by loosely coupled? To sum it up, if you have to redeploy your entire application when you make a change to one service, it's not loosely coupled. It means that you can independently deploy small pieces, in this case, microservices, at any point, and as long as you don't break the contract that you define, you should be good. Should be. There's some pitfalls we'll get into, but should be good. This drives continuous deployment. Most people will probably do continuous integration. Whether or not people do continuous deployment, it's a little bit harder, but it drives the ability to set feature flags, to do all kinds of different paradigms. There's a great book called Continuous Deployment that I highly recommend reading that goes through a lot of this, if you're looking for more knowledge on that. So they communicate via APIs. We're all here because we're interested in APIs. So, and that could be any API. It could be a REST API. It could communicate over SOAP. It could communicate over a message bus, passing protocol buffers around. They communicate over some API with some defined contracts. So when I say contract, I mean at the service boundaries, we define contracts. We define what you pass in and what you expect to get out. And we should try and make these backwards compatible generally. At Context.io specifically, which is the API arm of the API that I work on, we've historically just used JSON for this. We've moved, we're still using a lot of JSON. We're using protocol buffers, the v3, which Google has in, I think it's early beta now. It was late alpha. We're using that for a lot of things and exploring that for the internal side of things. Still, looking at building a REST API externally, but there's interesting backwards compatibility properties and other things. Different serialization protocols can help in different ways. It's all interesting, but at the same time, it's all still communication over an API and some sort of defined contract. We focus on a single concern, the Unix philosophy: do one thing and do it well. That's how we started out with our monolithic application. We tried factoring it well. We tried, we tried having modules that did one thing, and in a lot of cases we succeeded. This makes it harder for us to violate that. We can still violate it. We can still absolutely violate it and do terrible things, but it's a little bit harder. And it facilitates a modular design. And this is more of a property of, or rather a result of the above properties. Due to the above properties, individual services are therefore modular. So we can easily do things like have multiple versions of the same service out if we want, with some canaries. Doing that sort of stuff in a monolithic application is really, really difficult. How many people have deployed, the same monolith with different versions? Like that's great. How is it? Was it hard? Kind of. Mostly. Yeah, I can see that. Yeah, it's scary to me. It's something that I don't really want to do. So,
Be careful.
yeah, you have to be really, really careful. So what are advantages to microservices? So we've looked over some properties. Why do we want to go down this route? Technology choices. So you can choose a new language or framework for a new microservice. Not every problem is best solved by writing in Go, Ruby, C, whatever. Different languages do things better. Node was the first language that I know of that really had a really solid WebSockets library. And so people using it for chat services. Not surprising, Node did WebSockets well. But doing that, I know some people who are trying that in Ruby and with Event Machine, and if anyone's used Event Machine, it can be kind of painful. So you're not locked into previous technology choices. You can iterate and decide that, we want to do this, and we can choose the best library, the best application, the best language for that particular job, which is really, really powerful. It's they're composable. So we can take multiple microservices and compose them into a new service. An example. So let's say we have a service that OCRs receipts, or rather a service that OCRs pictures and outputs the text of that, if it's some sort of text base. If we have another service that takes a block of text and says, okay, it's a classifier. It determines if something's a receipt or not. So we compose those two together, and now we have a service that determines if a photo is a picture of a receipt. Just by composing two services together, two simple blocks of code at the end of the day. Pretty powerful concept. Small code base. So we're focusing on single concerns. So we have a much smaller code base. We can dive into the code and make changes because it's smaller. We have a better chance of understanding what's going on. In monoliths, like I said, there's this sediment. It builds up, and over time, there's fewer and fewer people that know what's at those bottom layers. You make one top-level change, it cascades down, or vice versa. You make something that seems benign at that bottom sediment layer that you don't really have a ton of knowledge about, and it breaks everything. You're like, well, what the hell's going on? We have a much better chance of understanding code when it's smaller and we know what it is supposed to do. Discardable. And if we don't know, and if we know what it's supposed to do, but we don't know why it's not doing it or how it's working, we can just throw it away. So if you have a microservice, system's dependent on it, the person who maintained it left, it is a spaghetti mess for whatever reason, or it's not performant, or it's written in a technology that doesn't work for the use case. Just throw it away. It's not a big deal. It's a microservice. It's, at the top end, it's probably 1,000 lines of code. It's probably average somewhere between 100 and that. So we're writing another language that solves the problem better. It might take a lot less code, might have a better solution, it might perform better, might be more maintainable. Whatever the reason is, not every language was created equal. Different languages have different properties. Doesn't really matter. Let's just do it in what solves the problem the best way. So this sounds really great. So it can't be as easy as I'm saying it is. And it's not. for simple systems, it can be pretty straightforward, but there are a number of pitfalls, and less pitfalls, but more things you just need to be aware of. And so I'm going to go over a few of them, and I encourage, if you're really interested in going down the microservices route, to understand those more. There's a lot of great literature out there on it. People who have built systems and done this over and over again. Read anything by Netflix, pretty much, as far as this stuff goes. They're probably the experts when it comes to scaling microservices. I mean, they're, 30% of the internet's traffic at this point? Something like that? Insane amounts of traffic, and they're at the forefront of this, and they embrace this and do great work. So highly recommend any blog post they have on this. So microservices talk over the network. There's latency. We're not running them all. So think about it this way. Think about microservices as just calling functions remotely, so RPC. Even if it's a REST API, just think of it as RPC. It doesn't really matter as far as this example goes. There's latency involved no matter what you do. Even if they're on the same machine, you're still technically going over some sort of network interface. It's going to be a lot faster, but still network-based. So if we want to create performance systems, we need to think about things a little bit differently. So this is a really simple example of something that's just serial. And this is what I would expect I would do if I had to communicate with multiple network interface or multiple external services in like a Ruby app I made like 7 years ago. This was normal, acceptable, which is sort of the way things were in a lot of cases, unless you were Netflix. So what's the problem here? It's, once this one's done, you're going to call that, and you're incurring network latency, and it's additive. It's going to take a while. Even if these are really fast, it's going to be slower than if you just had a monolithic system. So if this is better, well, how do we fix that problem? That's not good. Okay, there we go. Sorry about that. So can we do things concurrently? That's one idea. The other one is, can we share data between services? Not in a tightly coupled way, but more of a pass-through way. Like, let's say we have, common services like a user service, and we're hitting the user service in a lot of different things. Well, if your authentication or authorization layer knows about the user service and it hits it, authorizes itself, it says, okay, well, this next layer, teams talk, they can optimize things. This isn't tightly coupling. They can say, well, if we're passing a user, let's just use this user. If not, let's go fetch the user from the user service from whatever data that we know. But if we already have that object in some sort of CRDT or something, let's move that along. So the key is concurrency matters a lot, and I'm not advocating for specific languages for microservices. There's a lot that can do things. Go, Elixir, Erlang, Haskell, Rust, Java, Scala, Clojure, pretty much anything on the JVM because of Netty and other things. Some are definitely more intuitive than others. Some, like Go and Rust, have nice concurrency primitives built in. Some have interesting actor models like Scala. So at Context.io, we've been moving things to Go as our language of choice. For microservices specifically, we've been pretty happy with our decisions so far. Go routines alone make a world of difference, but really every...
Say go too many times.
Yeah. Monitor disengage.
It might be there, the other connection.
This is...
I noticed it had air display. You might want to try, AirPlay. You might want to try that.
Yeah, it usually disconnects me, but I can try. You got that? Okay. Okay, sorry about that. Thanks, Jason. So everything up here would work, and work well. There's really not a bad choice up here. They have different properties. All pretty good. So some pitfalls, some more pitfalls. Not knowing what's going on in your microsystems. It's pretty easy in a monolithic app to hook up a profiler to know what's going on. It's also easy to look at logging. It's all on one machine. So debugging what's going on is a lot harder. So distributed tracing helps solve that. So this is a picture of Zipkin up here. Anyone use Zipkin out of curiosity? Cool. So we're not using Zipkin. We built our own via log aggregator that we use, but essentially the same thing. So think of distributing tracing as a way to see what your application is doing from the moment a request hits an endpoint. Let's say an external request from the web. So someone from the web is hitting your site. You can track it all the way through all of the microservices it gets through until that request is complete. So you can see on here, there's different levels. It's almost like folders. So it comes in and it goes to some memcache, some big ass service, some final data service. This is on Zipkin's site, so they're pretty awesome. So you can see what it's actually doing, which is really, really important. You can see what, where's there a bottleneck here? It's actually not that bad. It's 112 milliseconds. Okay, not bad. There's a lot happening concurrently. You can see what they can get done concurrently and where they need to, all of this, all the stuff here was dependent on this, obviously. So you can get a lot of insight in your application and track down bottlenecks. I think this is table stakes for a microservice architecture. If you're not able to do this, then maybe not initially, but somewhere down the line, there's going to be some pain. And this will help solve that pain. So Zipkin was based on, I want to give some credit to Google. They had the Dapper paper that describes their distributed tracing infrastructure, and Twitter essentially implemented it, did a nice job. Think of this like the Chrome network toolbar when you're doing web development. Same thing. And fault tolerance, which has a lot of scary things on the page. And I'm not going to go super in depth. I encourage everyone to read up on this about circuit breakers and bulkheads and such. Really important stuff.
Chaos monkey.
Yeah, I was going to mention that one way to approach it is the Netflix method, which is turn some of your services off and test your faults. That's how you know if your system's going to fail gracefully. Just turn stuff off. They actually automate that in their testing. Like you said, Chaos Monkey.
Production.
Yeah, they do it in production, that's a scary thought. Yeah, it's pretty amazing. I call it their simian army of demons. So.
Have you seen the Chaos Gorilla?
Yes.
Yeah. It mimics taking entire data centers offline.
Yeah, they've like I said, if you want to do microservice testing, just look at what Netflix has done. Use some of their stuff, and if you can survive Chaos Monkey in your infrastructure and production, you're good. Nothing's going to take you down. Monitor all things. Gather data. Use a log aggregator. Shout out to one we use called Scalyr, SCALYR, which is really amazing. Some awesome guys who used to work at Google. Really great log aggregator. Add UUIDs to requests to track problems down. What I mean by that is, make sure that you can tie all of your log statements together for one request. We log 120 gigs of data a day. So trying to find something in there is pretty tough. You need something to tie it all together.
Correlation kind of ID.
Yeah, something where, you search for that ID and you can find every log line for that request, essentially. Use circuit breakers and bulkheads. So circuit breakers, they trip connections to services that are failing to respond for whatever reason. Could be overload, could be a lot of reasons. Think of it, overload's a good one because it corresponds nicely to the real world circuit breakers. What it does is it trips it and turns it off. Because what's happening in a lot of cases, and if you're using Chaos Monkey and you're using different things and you can fail gracefully, is that you're actually, let's say you have your Netflix and your recommendation engine has problems. And all of your requests, for whatever reason you've designed this, they hit the recommendation engine. So your streams could be slowing down because your recommendation engine is having problems. So turn it off, fail gracefully, at least have most of your infrastructure working in one way or another. And monitor the service, reset the breaker when it's healed. Bulkheads, they're essentially partitions. Partition your system. It helps you limit the blast radius when something does explode. You don't want to take your whole system down if one part breaks. And expect failures. Determine how you should handle them and fail them gracefully. So our infrastructure. So I've talked a lot about interesting things that sort of we've learned over time. So what powers the Connex.io infrastructure? So everything's hosted on Amazon Web Services right now. We're multi-AZ. We run a cluster on CoreOS. So we recently started using Kubernetes as of about 8 hours ago in production. It's pretty awesome. Thanks to Aaron Mills. It's pretty awesome. We're using it to schedule Docker containers. Like I said, it just hit 1.0 at OSCON. And we use GoCD by ThoughtWorks to build and deploy our containers. So we migrated to a Docker infrastructure for both the microservices we have and our legacy monolith that we've been tearing apart. I want to say end of March at this point. Without any special scheduling, balancing, whatever. We just kind of took the let's just throw it all in, throw some darts and see where it lands approach. We were able to lower our infrastructure and our costs required by 33%. Just by nothing else other than putting it on Docker and doing some, minor tweaking and balancing. Just because, we were burning AMIs and putting them up on machines, and some were highly utilized, some weren't. Just did a better job of balancing them naively with Docker. And we were also able to spin more up in development. Just easier to get people onboarded, etc. So we're now working on tweaking Kubernetes scheduling and getting everything on there. Have a subset of things. Really, really hopeful for that. Like I said, we're using Go for all our new stuff, so obligatory Gopher up there. So this is from the CoreOS website, and this is a pretty good. This is a really simplistic view, but it illustrates well what we're going for. There's a lot more going on in our infrastructure. But this is an example of a 3-tiered app. Like I said, ours is more complex, but it's a good way of presenting the principles. As you can see, we don't actually care where these containers run. It doesn't really matter. What we care about is that we have a certain number of them running and that they're distributed amongst the hosts in a way that gives us redundancy. So we have a database container running here. In all likelihood, we would run a few in each and a few web containers. In reality, we have, 60 hosts like this where we run hundreds of containers and distribute them across. So, good principle sort of outlook. So next, I wanted to go through GoCD briefly. This is GoCD, it's by ThoughtWorks. It's been around for a little bit. So what we do is we use it to build development pipelines. And like I said, we've been trying to get our developers to practice DevOps more. And we've had great success with this. So developers can, with some of the templates we've made, create a deployment pipeline and have a new reachable service in production in 10 minutes. So locally they've developed it. They say, I want to deploy this and put this out and have this production ready. It takes about 10 minutes. So we have a lot of these. This page goes on for a while. They're vertically sorted and then scaled horizontally depending on how complex your pipeline is. Let's dive into a couple interesting parts of the email sender service, which is a good story. We actually had in our legacy app some issues sending email. We had to make some emergency changes for a developer on our API that was pretty big after Google deprecated some OAuth 1.0 keys. And so in doing that, we actually broke our ability to send email. So what we did is we spun up this extra Go service that we extracted all our emails, built this little service, and then deployed it out, and just had to had to communicate to that particular service. And we're able to eliminate this sort of code conflict that made our current system just break. So this is, it's pretty straightforward. We have a template with a couple other options set, very minor, but we just give it the GitHub repo, which, as you can see, other inbox/email sender service. Pretty straightforward. In that repo, there's some Go code and the instructions in a Docker file about how to build it. That's it. Then we create a deploy pipeline. And so that was really quick. This is the build pipeline for the email sender service that builds the Docker image. We don't build it each time we deploy because for some things it can be relatively complex and take a little bit of time. So we want a little efficiency. So this is our deploy pipeline. As you can see, we have the port defined we wanted to listen to. For any web ones, we always define it on 80 because they essentially are root access boxes, these self-contained containers. The container name is email sender service, email sender services cluster, and we have 2 of them. For redundancy's sake, we don't actually have enough load on it to merit having more than 2 of this Go service because it's just chugs along. So this turns out to be, after we deploy it, internally accessible based on the service name. So in this case, for us, it'd be email-sender-service private.context.io or something. So whatever our VPC internal mapping is. So fully addressable once it's deployed. Listens on the port we want. And we use, for this, we would use just SRV records to round robin it.
Do you do any service discovery, or is it all?
So we do in some cases. We use console in some cases. We're doing some with etcd. So we're still sorting out exactly how we should do that in the long term. But yeah, we use some service discovery. For this though, we're not. It's just simple. It's just simple enough to use an SRV record and round robin. It listens on a web port. It really doesn't matter.
To use DNS?
Yeah, for that, yeah. That particular one. So that's all I have. So any questions, if anyone's interested in sort of seeing, I know a lot of people have Docker experience, so it might not be as interesting to see the Docker demo of just running a Swagger editor, willing to go through some stuff. Any questions on anything? Yeah.
We just talked about etcd and console. Are we using that in dev too?
So some of the people on our team are using console in dev. So I don't know of anyone right now that are using etcd in dev. Yeah.
For your Kubernetes cluster, how did you size it? Because it's not like the cluster auto scales perfectly. I mean, how did you take
I don't know. So you can message me on Twitter, and I can ask my senior DevOps engineer, who was the one who did all of that. I don't know how he ended up sizing it. But he took care of that. I'm willing to ask him and let you know.
Cool, thanks.
So what are you guys using for a database, and what is the struggle you have mounting disks?
I really don't want to say what we're using for the database. Dan and Bonnie know it. So we use a lot of different data stores. Okay. So I'll let you finish your question.
Yeah, well, it's persistent storage with Docker is a little funny.
So we don't Dockerize our storage, actually.
Okay, so
our databases we don't put in Docker.
Okay.
So we try and use anything. We try and veer towards managed data stores by Amazon that have an open source corollary. Like there's React for Dynamo, any MySQL for Aurora and RDS, stuff like that. So we don't Dockerize any of that.
Okay.
We use bare metal because of the performance requirements. We use Mongo for some of it, which we're moving away from. But had we had a better sharding strategy, I think Mongo would be okay, and probably Cassandra would be okay. Anything distributed like that, I wouldn't run. I don't see a reason to run MySQL on that. So.
Your services kind of independently have their own data stores?
Yes. Yeah, we follow 12-factor for that stuff. Yeah, definitely.
Share the database?
No, nothing new. We have a few legacy items that share the database. Anything new we write does not share the database. That's one of the things we operate on is let's not use, in Docker, let's not use any of the ephemeral storage. Let's pipe everything out like logs to an aggregator that gets then sent up into the cloud to a log aggregator. So we use Fluentd internally. So yeah, we try and, we violate it once in a while for business cases or for, because of the legacy system. But anything new, we try really, really hard to follow 12-factor.
And your environment variables, they're all if you have a ton, do you always put them on the Docker file, or do you have
No, so that's just what Swagger does. We actually put all of our environment variables in GoCD. Yeah, so there's a secure params. We've looked at Vault by HashiCorp as well, and long term we're probably going to go the Vault route. We're still deciding what we want to do for that long term. Right now, the GoCD route seems okay. I have run into problems though where there have been passwords with percents or other Unix special characters that when you put on the command line do funky things. And so when that happens and you put it in an environment variable, terrible things happen and it's hard to figure out. So avoid percents or any shared special Unix characters in that, or URL encoded. That's the way I got around it.
So if you have a Python, you have local, the settings and all that, you try to convert those, extract as many of those into environment variables?
It depends. Like passwords and such, absolutely. In most cases, yeah.
Okay.
Back there.
I know it's not recommended for production yet at all, but did you guys take a look at Docker Swarm at all?
Not yet, no. I have a friend who's been messing with that, who's been sort of doing that and Kubernetes at the same time. So I'm interested in what he has to say about it, but we haven't done any of that yet.
How do you handle user to microservice and microservice to microservice authentication and authorizations?
So right now we don't, because there isn't any at the moment. So the way we're going to handle it in the future, like we're throwing out a few ideas, because we're going to be breaking our authentication layer out and moving it in front of all of our services separately. Like I said, we have for all authentication and authorization, we have sort of this monolithic app structure in front of things. So right now we don't do anything about that. I sort of have been throwing around the idea of, like I said, breaking the authentication layer out and then passing the user through as like, if anyone's familiar with Go in context, sort of like you would do in Go with the context, or at least passing, the user ID and their authorization scope, like what they have access to, and then having those back services not do authentication, but just check that they have resource authorization. So, we're still working through that. We haven't had a chance to implement it, so that's sort of our thoughts, at least so far.
Have you had to deal with some refactoring because if the services are too chatty to make them less back and forward? If there's had that problem at all?
Not yet. We've had to refactor a lot of logging that's too chatty. Different problem. We haven't had too many problems with that yet, at least internally. I suspect we will. Like I said, we probably have like 10 or 11 microservices. We still have this big monolith that we're going to break it out, and we'll probably double the size of that. And some of those will be a lot chattier, and we'll do a lot more. We do have one case where we have sort of this Ruby, this node-backed microservice, and for whatever reason, a Ruby load balancer in front of it. And that, that gets a little bit overloaded at times, so we can just auto scale that. So we plan to replace that with HA proxy or something to do consistent hashing, because there's locality that matters, connections that are held in that node service behind it, and so it sort of manages contracts, but it's not really necessary with consistent hashing. So we, it's a matter of just finding the time to change that.
So from what you said, you've been actually running Docker in production for about 5-ish months.
Like, yeah, 5, 6, yeah.
So, what part of it sucks?
Some part does.
So Flannel for a little bit was really rough, which is the overlay network that is addressing. We've had SkyDNS containers randomly die, and that's caused our cluster to have run into problems because the services can't communicate them because they don't know about DNS. We've lost etcd, that's caused us to lose the whole cluster before. So we've worked a lot as we're in a much more stable spot, but yeah, there were a lot of production issues that we had to sort through. I think with Kubernetes, a lot of those are a lot simpler. Google's done a really nice job, and we won't need SkyDNS anymore, for instance.
At least the last 24 hours tells you so.
Well,
last six or seven, something like that. I trust my lead DevOps guy. He's pretty good.
But it sounds like most of the problems you saw were this or that breaks, and you work through it and you get it stable again. It's not so much, it's nearly impossible to do, or this other thing over here is just hard to.
Not that I've
just mostly the stability stuff.
Some of the DevOps guys on my team might have run into some problems that impacted stuff. I'm not aware of decisions that were made because something was impossible. Usually things aren't impossible. Sometimes it's just more painful. We definitely had our share of pain points moving to Docker. Definitely, especially without Kubernetes out and using Fleet for scheduling initially, which wasn't intended to do scheduling, was more to do like distributed init sort of stuff. I talked with I go over on Kelsey Hightower, and like they're happy that their fleet's going to go back to what they intended it to be. We used it for scheduling. It was never meant for that, but it worked, and we stabilized it. So I think the pain was well worth it. We're definitely able to do things faster.
So is there anything in the current infrastructure that you would say
Talking out of turn. Dan Corbin.
Is there anything in the current infrastructure that you would put an asterisk next to and say, this is the current infrastructure, but I could see a year from now us swapping, say, flannel out for something? Is there anything?
So there's nothing to replace flannel right now that I know of.
We don't have, I don't know if you know, they did a big OpenStack and they're saying they have a solution for the overlay.
Oh, well, that would be interesting. Although I feel like it has stabilized finally. Part of it was we were sending hundreds of gigabytes of traffic through it. It wasn't really quite ready for that.
They presented at the OpenStack, and I think they mentioned with Kubernetes to make their stuff work and kind of.
I'll have to mention that to the DevOps team. That'd be interesting.
It's called MutoNet. I think they just became open source. They were private for neutral platform.
How did you go about selling Docker internally? Was everyone so excited to get off the monolith, or did you have to go?
So it was already decided. So the Austin office, we're a satellite office. So Return Path has a lot of offices globally. Our main financial centers like New York. Most of the engineers are in Colorado. We have a handful of engineers on my team in Austin, and then one in Colorado and one in San Diego. And so they were already doing it in Colorado. And we just sort of did it our own way in parallel and did it really quickly. I'm not sure how they sold it in Colorado previously. When I started a little bit over a year ago at Return Path, so when I started, the wheels were spinning a little bit to investigate it and such. And so by winter, we had the requirement from our SecOps team to move everything into VPC. And so we just said, well, we're moving, let's move to Docker too.
Cost savings was 33% reduction.
What's that?
What is the 33% reduction in cost based around density?
Tens of thousands of dollars. I mean, yeah. Oh, what's it based around?
In terms of
just density. Density. Specifically density. We're able to run. We're able to do more on less because we have better balance. Even doing it naively, it's just better. So.
On your slides about the Docker benefits.
Yeah.
It didn't seem like anything really took advantage of the various union files or the overlay file systems or union file systems that they use. Especially since, like in the example Drfile, a lot of them were npm installs that would not really be caught by that anyway.
Yeah, so that's not our Docker file, so that's a swagger one. So we're not using any of those right now. What would be the benefit? So I'm not super familiar with that. What would be the benefit?
I mean, so like the way they sell it, I think, is that so if you were to make a change on one of those lines, for example, you wouldn't rebuild the whole thing, and that's what allows you to like take the original Ubuntu image, bring it in, and then build the extra stuff on it.
Yeah. So we're not taking advantage of that for anything that I know of right now. We are obviously for any of the base images because that's the way they're brought in.
Yeah. So like. Because my understanding was like the core of Docker was that, and then so first LXC and now just lib containers, secrets, whatever. And they have like pluggable backends.
Yeah.
For execution backends right now for that. So is it mostly the interface that you like about? I mean, I use it as well. So.
Yeah, the interface is big. How we can schedule things is really big. How you can define just a whole environment. I mean, you could achieve a lot of those in virtual machines, but this is a more lightweight way of doing it.
Right.
It's more portable.
The last issue that's more of a weird personal one for me was I noticed that so certain things I don't know if you're able to control. Like for example, I ran into iNotify watches shared across the system, which means a single container could just.
So we have had. So yes, so when we first did the mail service, the email sender service rather, I actually did something wrong and it was thrashing and it took down one of the hosts. It didn't take it down fully, but it definitely caused a degradation in services. So yeah, so you can definitely have that occur. I believe that that's going to get better over time. It's still significantly better than where we were and still worthwhile, but yeah, that's still a problem. I think Kubernetes has some stuff around that because you can. I'm trying to think. So we're getting a lot of our stats through cAdvisor. Yeah, there are ways you can granularly control that, but we're not doing that at the moment, and we should be. but it's more a matter of we've been running it for a while and gathering data and trying to understand, well, how do we tweak those sorts of things and how do we do it? But yes, I've absolutely taken down a host for reasons of thrashing and having essentially the Go code wouldn't compile, made a mistake, didn't get it caught in the test somehow, and it literally was just continuously trying to restart the container, and that alone, it was doing it so quickly, it just caused thrashing on the machine. So yeah, it definitely could happen. Yeah.
When you guys were trying to break the monolith, the journey migrating to Docker, what was the criteria of trying to define what should be in that Docker versus creating multiple and then using Compose to put them together? There's all this confusion, single process, run your entire app. So how did you guys go about it?
So we put the monolith in Docker first. That was step one, is we put everything in Docker for the most part. We have 2 things that aren't running in Docker that are at least in VPC that we need to move to Docker out of 8,000 or 6,000 containers, something like that. I mean, we have a lot of running containers. But our solution was just our legacy deployment was really hard. So when we would have to build a new box to deploy it to, it would take a lot of time. Even automating with Ansible was difficult. So Docker solved that problem of a reproducible environment for us.
But how so? Because I mean, in Docker you still have to specify how you.
Yeah, but so once we were able to figure out our system's unique and we have a lot of environment variables, all kinds of different things that we had to collect together. Trying to explain it without. It was just easier. I think part of it was people were more motivated to figure out. We had one DevOps person who was really motivated to get us on Docker, and so he sat down and figured out all of the different things we would need to do to run it elsewhere, instead of cloning an AMI and running some Ansible scripts. So part of it was there were environment variables sort of embedded in this AMI that had been around for like 2 years that no one knew about. So it was trying to figure that all out and migrate it over. Does that make sense?
Yeah, because I mean Drfile is a mini batch.
Yes, it is.
There, right?
Yeah,
so installed, which is provisioning that. So you can reconstruct that with traditional provisioning tools, but it's trying to see
part of it was that archaeology work that no one really wanted to do, that sort of motivated them to do it. There's a question back there. No?
So what would you say is the ratio between like HTTP versus asynchronous message bus or message queue communication, and have you seen any trade-offs between those?
So we have a lot of both. So depending, the message queue we're using right now that I want to migrate away from, like I said, for the legacy stuff, we're using a few message queues. We use Kafka very heavily. We see really great things from Kafka. We use Gearman for a worker queue, and we see terrible things from Gearman, and I want to throw it out. I want to replace it with the Rabbit or something else. I would replace
things with Rabbit. So
what's that?
We see terrible things with
Yeah?
Rabbit, so careful.
Okay. I've used it previously, and I don't know how it's still working for you, Matt, but
pretty well.
Okay. Yeah, so I want to move to something a little bit better than Gearman. I would be okay with SQS, except the legacy is PHP code, and so in my experience, and we saw this at Silvercar, we would see random, a random put to SQS would take anywhere from 50 milliseconds to 100 milliseconds. And if you're doing that in the middle of a web request in PHP and you're blocking and you can't do it asynchronously, if you don't have CSP, you can't do a Go routine, you can't do anything like that, you're blocking for the whole web request, and then you're in a terrible place. So we're seeing good things from both overall, sans Gearman. You have a question?
Oh yeah, so you said that your DevOps guy was really motivated to figure out the sort of the archaeology aspect.
Yeah.
Was that because Docker was the right solution, or is it because Docker was a cool solution?
It doesn't matter.
Yeah. A little bit of both.
A little bit of both. I mean, I think that we've been moving towards. For the past decade, we've moved towards VMs, and I know a lot of places move towards burning AMIs on Amazon, and this is just sort of that progression to something more lightweight, more developer friendly. Giving more computational agency, developers practicing DevOps more. It's a progression. So, yes, it's cool. Could it have been Rocket or something else? Yeah, absolutely. But I think that it's a progression towards containers that we've already been embarking on.
And it's the big thing, I think, in my view, is that standard that people are trying to standardize on that Docker layer, the shipping.
Yeah, even Rocket is at this point.
Right, whereas the AMIs would be only a mountain.
Yeah,
that's
exactly.
the big difference, I think, there.
Exactly.
Yeah, I'm just curious about how you determine, I guess, how many Docker instances can reliably run on a particular box, like hardware box. If you don't want to put like 30 Docker instances on there, so like, how do you determine that?
So we were,
especially after the like I notify discussion you guys had before, like.
So mostly in monitoring, we use Datadog for monitoring our cluster, and so we look at what's running there, and a lot of it's been some of it's been naive, just putting stuff out and seeing if stuff falls over. Some has been tweaking that a little bit, but like I said, we want to go back with Kubernetes and tweak the scheduling a little bit and actually put properties around things, and so I'm not super familiar about how to do that with Kubernetes yet. Like I said, the DevOps team just put it out into production today, so. We'll definitely go down that line. So far, it's been mostly hand tweaking and understanding about how much to put on each machine and then monitoring the overall cluster. We have pretty beefy machines overall. We've actually, even though we've reduced our cost by 33% and what we need, we're still way over provisioned just because we're still learning about it. So that's sort of how we solved it, was we over provisioned, and we're gonna start pulling back a little bit to try and find a little bit more savings here and there. But we were able to find a ton without doing much. So it's like, let's go with this win and gather data.
Two things. One, can you put your contact information back on the screen? And two, last question.
Dan Corbin.
Are you hiring any software engineers?
I am absolutely
developer engineers.
So Return Path is usually hiring software engineers all over. My team, so we just hired a software engineer. So right now I'm not hiring a software engineer. I am hiring a DevOps engineer right now. And feel free, if you're interested in what we're doing, like I said, we're doing everything in Go, get in contact with me because we will be hiring later. That's the way it works. We're a growing team and we're doing really cool stuff. So, when the time comes we're hiring, I'll already know who you are.
Cool. Thank you, Michael.
Yeah. Thanks for coming out.
Okay, a few quick things. First of all, thank you to Context.io. They are our food and beer sponsor for the evening. So let's give them a round of applause for that. We all eat and drink for free because of people like them. So be sure to give them a high five or something on the way out.
Dan Corbin likes high fives.
Or shake their hand, whatever's appropriate.
High fives.
High fives, okay. Quick rounds going through the room. Who's hiring? Recruiters, don't stand up. If you're hiring for your company, stand up and say, here's who I am, here's who I represent, here's what we're hiring for.
Karim, I'm data engineer at Civitas Learning, an awesome startup company with all the perks you guys know. In the world, we are hiring tons of people, like data engineers, most definitely, software engineers as well, and data scientists, sales, and marketing. So whatever is you are really wishful. We are doing crazy.
Cool, thank you. Next, somebody over there.
It's not my business cards, I have one, sorry.
Okay.
I'm Ed Vineyard. I'm with UShip. We are hiring developers. We've got a DevOps position, a DBA position, an IT position. So come see me.
Full shot now. All on it.
Yeah, we're starting to do microservices. Well, believe it or not, on Windows. So
UShip was our longtime host, so they're an awesome company. Anybody else over here? Hiring? Anybody over here? Oh, there you go.
I'm with Honest Dollar. We're hiring infrastructure, front end. That's pretty much the whole stack right there. But we're using Go. I don't know about this, like using Kubernetes after they launched. Like we were in the beta. It was awesome.
Wow.
It was ballsy, but
focus on what you're hiring for right now.
Yeah, infrastructure, full stack. Come talk to me. I'll be around for a little bit.
Anybody else? If you're looking for work, I'm not going to ask you to stand up because you don't necessarily want to let your colleagues know. But see, these are a handful of people hiring today. Let's see, any cool tools that somebody find in the last month or so that you want to share about? Cool tools, APIs, anything else? Nothing.
I was bringing up Spire and Reflector.
What's that?
It's like a brand new thing that the Spire team is putting together, and a lot of Spire interest in here. And it's basically like a library for putting together a whole API in Java, starting with a Spire definition. And to
my knowledge, it's the first sort of design first thing from the official Spider repos, so that's pretty promising. And I think it's a good lead-in for all the things they have working in the background.
To riff off of that, Ken Lane, the API Vandals, has come up with a library of a bunch of different API design guides. I believe PayPal is one of them. And is publishing all those. There's a list of like 10 of them. I believe it's APIVandals.com.
Yeah, but it's on the 3-scale blog.
Okay, it's on the 3-scale blog. So if you Google Ken Lane, you can find his site, and it's API design guides. There's like 10 of them right now, and he's trying to sort of aggregate them to come up with like, one set of rules to rule them all. Any other cool tools, things you find? Yeah.
It's about another meetup. It's on October the 19th. I'll be presenting you guys additional statistics and data analysis. I'll be presenting a package, RPy2 Python package. If you're interested, it's all about using R and Python all together. So I'll be doing the talk. Feel free, please come and just new stuff.
What's the name of that meetup?
It's a data meetup, and I'll also check in with the R meetup group, Austin, to see if I can do the same talk there. So feel free.
Excellent. So with that, I think we're done. Don't forget. Yeah.
If we're talking meetups, and you're interested in Docker stuff, there's Docker Austin. Their next meetup is actually tomorrow night at the Rackspace offices at 6 p.m. They're going to be talking about Docker images and doing some lightning talks as well.
So the Docker Austin meetup talks about Docker. Correct. All right, so everyone got that? Okay. Sorry, I had to give you a little bit. So everyone, that's it. We're done. Don't forget the call for papers or call for presenters for the API Strategy Conference is still open for like another 6 days. If you Google API Strategy Austin, you will find all the details. It's a real quick thing. It's a 15, 20-minute presentation. Talk about stuff you're passionate about. And with that, you don't have to go home, but you have to leave here by 9. All right. Thank you for coming, everybody. Don't forget Austin API.